minutes, but let me talk about few things that I have. I just want to talk about 3 cases because, okay, so I was talking about derivation of equations of motion, if you remember, but I have to stop for 45 minutes. I really want to talk about this thing because I will also post the past final exam and you will see that we still have 5 minutes, by the way. You can go and come if you want. But you will see that since many of our questions from our past paper at least came from rigid body kinetics, there are a couple of confusions and I really want to talk about them. So remember that I am trying to make 3 cases right now, although this is now how we talk about them, because you need to know these 3 cases. I think, again, these are my own interpretation. Remember that we usually tackle the problems like this. Forget about the summation of forces in the X and Y. I'm sure you already know that. I'm just talking about moments. Please bear with me. Hello? Okay. IG alpha. Where is the pointer? IG alpha. Then there is another way of handling that. We talk about summation of moment about a point of rotation is equal to IA alpha. Now remember that usually, not usually, in fact always, this is fixed point of rotation or fixed axis of rotation. Now if you look back in your notes and see all the examples that I have done, it will make sense. Now for this one, we don't care, DONT, whether it's fixed axis, whether the axis of rotation is fixed or the object is translating. So if you have a wheel, it is going towards the right, we are still doing summation of moment about point of rotation is equal to IG alpha. But for the same wheel, if you remember, when we were trying to anyways, forget about that. Now, what about fixed axis of rotation? For the case 2, you can remember this example that I did, a rigid rod, right? So if you remember for the rigid rod that I did, what was the axis of rotation for the rigid rod? It was this point, right? So I was doing about this point A, summation of moment is equal to IA alpha. What is this? This is a point of rotation, that's fine, but it is also fixed axis of rotation. This is not going anywhere. Now inside this, I still remember I talked about, you can always write it as IG plus MAG multiply by D or R, whatever, multiply by, I'm sorry, MR square. Hang on. Sorry, AG. Did I miss anything? Hang on. I think IG plus MR square multiply by alpha. So we were doing all of these things. Now I will talk about the case 3 today. Remember that when your point of rotation is not fixed. Now again, of all the practice problems I have sent you, you might have done it. You might have noticed. Remember that you will have 2 components. One will be IG alpha and the other component will be MAG. This is what I am trying to tell you, that when your point of rotation is also moving, you will observe that now your life will not be as easy as just I alpha. Always you will have an MAGD term. Now for students who have been attending our classes, they might have observed that, you remember that car problem that I did on the whiteboard, or the motorbike problem that I did on the whiteboard. If you remember, even in those problems, the MAGD term was appearing because we talked about the fact that in pure translation, I hope I'm not confusing you guys, but anyways, in pure translation, I still remember I told you this, that in pure translation, of center of mass. I still remember I told you guys that summation of moments is equal to, so we will have I G alpha plus M A G D. Which was the term that I used to remove? Anyone? This term, you remember that? This I still remember for students who were attending. I still remember I did that on the whiteboard. I still remember the 2-3 students who were sitting here. This I have already told you so many times. This I have already told you. Case 1 so many times. Summation of moments about center of mass is equal to Ig alpha. Your center of mass itself is going towards the right or left. I don't care. Your center of mass is sitting right there and the disk is rotating. I don't care. Summation of moment about center of mass is equal to Ig alpha. I know. So you should not have any confusion here. Then for this one, you should not have any confusion. The case 2 is for this rigid rod, summation of moment about the point of rotation is equal to Ia alpha. We all know it. We don't need to get confused. You can also write this as Ig plus Mr square multiplied by alpha. You should not be confused. Right now, I'm focusing on the case 3. What I'm trying to tell you is that if you look at this problem that I'm showing you. Again, this is not to confuse you, but to explain to you. I will post the past exam as well. So solve it for your final exam preparation. This is the case 3. Your point of rotation is going, the point about which this rod will rotate is going to the right. What I am saying is when you have to write summation of moment about A, just don't stop at is equal to I alpha. You have to use one way or another Ig alpha plus MAGD. So please remember this. The reading files that I have been posting on O2 class, open that, general plane motion, double click on it. Hibbeler textbook clearly talks about this, that when you have a fixed point of rotation, then life is beautiful. And you talk about when your point of rotation is fixed, you talk about summation of moment about point A is equal to Ia alpha. This case, this rigid rod is rotating about this. When your center of mass goes to the right, goes to the left, or your center of mass is fixed at a point, you don't care. Summation of moment about center of mass is equal to Ig alpha. We have no problems. When you have a pure translation problem like a car motorbike problem that I did in this class, summation of moment about any point on that body is equal to Ig alpha plus MAGD. For pure rotation problem, I always used to put this 0. Today, I am focusing on the fact, what if this point is also moving? What I'm saying is just remember that in general, you will have to use this, and it is very easy to get confused because we are so used to doing summation of moment is equal to I alpha that you will end up forgetting this. Okay, now if I were you and I had a final exam in just 3-4 days and I was saying, oh, come on, I really need to organize everything that you are telling me. My recommendation will be that you quickly open your rigid body kinetics slides that I have been writing here that are available on Google Drive. Go over the rigid body kinetics problems every time I have applied summation of moment is equal to I alpha, and just observe. Okay, so rigid rod problem, do it how I did it and just try to corroborate with what I am writing here. And the wheel problem, it's going to the right and I was doing summation of moment about center of mass is equal to Ig alpha. Double check whether I am right or wrong, that even if the disc was fixed, hinged at that point, I still used Ig alpha. If it was going to the right, translating as well as rotating, I still did Ig alpha. Just one more comment I will talk about. Okay, I said summation of moment about point A is equal to I alpha. Okay, I think I have talked about everything. Now let's do this problem that I have brought here. Then I will go back to teaching you about that equations of motion thing. Now, just to make your life easy, the equations of motion that I was doing in the class, if you remember, I started Euler-Lagrange. You remember that? Euler-Lagrange is not coming in exam. Euler-Lagrange, derivation of equation of motion by Euler-Lagrange is not coming in your exam. Done? Equations of motion by Newton law, of course, it can come. Thanks for your patience, everyone. I really appreciate it, because I know going over anything that is a bit new is hard in the last class. So I really appreciate your patience. But at the end of the day, when I was going through the practice problems myself, how to help you guys in your exam preparation, it just hit me that you might get confused over this concept. That's why I'm going over it. This is the first time in my class that I have come up with this example. So let's do it. Let's put this example to test. Number one, the question says, okay, I wish I had brought this. The 12 kilogram uniform bar is supported by a roller at A. Okay, I think it's pretty clear. If a horizontal force of 80 Newton is applied, so let me zoom it in so you can at least take a picture, is applied to the roller, determine the acceleration of the center of the roller at the instant the force is applied. Neglect the weight and the size of the roller. Is the problem clear? Okay, so let me at least write down the fellows for you so you don't get confused. Number one, what is given to me as F is equal to 80 Newton. Done. Second thing that is given to me is the mass of the uniform bar is 12 kilogram. Okay, let me pin my own picture. Okay, then we have determine the acceleration of the center of the roller at the instant the force is applied. Okay, determine the acceleration of the center of the roller is equal to question mark. The mass of the roller is negligible. No, it's negligible. The mass of the rod is ROD. Okay. Now, neglect the weight and size of the roller. Number one thing is the free body diagram. You can see that I have saved my time by making the free body diagram. Summation of forces is equal to MA. So let me just show you the free body diagram. We have capital F to the right hand side. The normal force is applied on that roller to the in the upward direction. You do realize it, right? Because it is sitting on that table, right? So normal force is applied on that roller. Center of mass is this point. There is a weight of the rod as well, which is 12 into 9.81. So students are getting confused. So I will make an arrow like this. Why there is an equal to sign here? Oh, come on. Summation of forces is equal to MA. So the author has made a kinetics diagram and just multiplied this with M. I hope it's clear. This is how the author does it. I usually in the classes make the free body diagram, and then I also make a kinetics diagram in which I show the accelerations. But if you even do this in exam for every problem, it's so cool, right? Because you are putting an equal to sign and you are just multiplying the accelerations with M and the angular accelerations with I. Now you can help me with the problem. Trust me on this. If you understood what I told you before, so let's do it. This is summation of moment. Where is my point of rotation? A, right? If I am applying the force to the right, of course, the rod wants to go to the left, right? So there are absolutely no qualms. There are absolutely no qualms where the summation of moment would be. Come on, it will be about the point of rotation, right? Like I'm not going to write summation of moment about center of mass is equal to IG alpha. That's ridiculous. I have to talk about the summation of moment about the point of rotation. We always do that. So there are no qualms that I will write this, because if it had been like this, oh, come on, this, then students who write this, I have no problem. But even if somebody says that this is no slip condition, even if we had a student of our class who had tried to solve this question by this, again correct, because again a no slip condition means the point A has zero velocity. And I have shown you in those cases that whenever your point of rotation is also fixed, you can use summation m is equal to I alpha. Life is beautiful. But you can see that for this problem, what I will write is, let's go back to our, so I will just take a liberty to put a minus here, right? This point, if all the students can focus. So I am writing plus minus here depending on the situation for our third case. Okay, so I will actually talk about my third case now that, oh come on, I will write summation of moment about point A. What are the forces? By the I will have to put a zero, right? Because I do not see any moment. Now, if, for example, I had applied a moment by my hand, of course, then I would have put a capital M, like let's say capital M naught, and I will have put a capital M naught. But since there are no applied moment, zero. Now I will write this is equal to I A alpha. Oh, come on. Then I will have minus whatever, I A alpha minus or whatever, plus MAGD or minus whatever. So it will be, give me 1 second. Yeah, plus MAGD. In fact, even in those cases, I will put plus minus, whatever. I don't know. We have to come up with the signs ourselves. So I don't know, minus, plus, whatever, depending on whatever signs. So here we will see that if I have this feeling that this rod will have an alpha clockwise, then probably you might want to put a negative here. I don't know. And again, if I have a feeling that the center of mass acceleration will be towards the right, I will put a plus sign. Now, if somebody is applying the force to the right, where will be the acceleration of the center of mass to? Of course, to the right. So that's why my MAG multiplied by D will give me an anti-clockwise. Whereas if I apply the force like this and the rod has an alpha clockwise, that's why I can put a negative here. My point is there will be a plus minus. You put a negative here, you put a plus here. We can't care less. And finish the question. Not IA alpha. I apologize. Did I write? I write IG alpha. You see, so easy to make these little mistakes. I made a mistake even copying my case. So now I will write minus 1 over 12 M L square alpha plus. Now I will write mass of rod multiply by AGD. By the way, can anyone tell me whether I'm talking about AG means this acceleration at this point, or I'm talking about acceleration at the center of mass? Center of mass. So it's very easy to get confused. When I have an object, I am applying a force. You can easily fall into this trap. Well, I am applying force at that point. So I'm talking about that acceleration. No, you're talking about the acceleration of the center of mass. Summation of F equal to MA means wherever you are applying the force, you're talking about the acceleration at the center of mass. So easy to get confused. So thanks for the comment. Now I will just finish the question. The question for me is pretty much over. Minus 1 over 12. The mass of the rod is 12 kg. The length of the rod is 2 meter. Power 2 multiplied by alpha plus, I will use a separate color. Mass of the rod is 12 kg, I think. Multiply by acceleration AG, I don't know. The distance D, I think is, sure, MAG multiplied by D is 1. Okay, I will agree with our students who are saying it is 1. And this will pretty much finish the question. Now, as I was struggling, what on earth is happening? I know that summation of forces in the x direction is equal to MAX. And it is equal to 12 kilograms into AG. Good. And yes, AX and AG is the same thing for me. In fact, I completely agree with him. Let's be careful because again, it's easy to get confused. And last but not least, what are the summation of forces in the X direction? It is 80 Newton. And I will finish my question by talking about 80 Newton divided by 12 kilogram is equal to AG. And AG comes out to be, I don't know. And of course, X always helps. 6.7. So it is equal to 6.7 meter per second square. Boom. Now acceleration of center mass is done. Now the last piece of the puzzle is, what was the question? The question said, determine the acceleration of the center of the roller. What will be the acceleration of the center of the roller? Anyone who can help me with that? So acceleration of the roller will be AA is equal to question mark. So AG, anyone? Is equal to AA plus the same story, right? Alpha cross R G with respect to A plus omega cross omega cross with a bracket R G with respect to A. And the next two terms are a joke, right? We are not going to use them here. So it is equal to, what is AA? I think it's a question mark. But what is the direction of the roller? It can only go in the right or left, right? So there is just no way that it will have a Y component. Now be careful. Be careful. Be very careful. The roller is also only going in a flat horizontal path, right? In instances when you have an object that is rotating, then we can easily fall into the trap, right? We have to be careful that an object that is rotating will have two components, right? Tangential and normal. Here life is easy. Oh, come on. We will only have one component.
Could you explain the moment of A part?
Summation of moment of
minus IG alpha.
Minus IG alpha plus MAGD. Okay. So first thing first is, let's go step by step. The summation of moment has to be done about point of rotation. No qualms about it. Come on, the rod is not rotating about its own center. It is rotating about a point, and that point is A. So summation of moment about point A, I have to write. Now summation of moment about point A is equal to, I know that on the right hand side of the Newton's equation, I have MA, I alpha, all of those chunks. So that's why on the right hand side, I need to have, because it's moment, it has to be I alpha terms. Oh, come on. I cannot have MA. So I knew I need to have I alpha. The only catch is that I just told you a few seconds back that whenever you have a situation where you are doing the summation of moment about a point of rotation, and that's not a fixed point of rotation, then you will have, instead of apart from IA alpha term, you will also have MAD term as well that will pop up. Now the only question that is left is, how do I come up with the signs minus and plus? Well, first of all, when I am pulling the roller or the rod for that matter to the right, I have this intuitive feel that the acceleration of the rod might be to the right. But at the same time, I also realize that the alpha can be clockwise. It may be clockwise. It is possibility that the rod might want to rotate clockwise. If this explanation is not good enough, and if you end up putting a plus, both of them as plus, would the answer come out to be wrong? I'm not sure. I don't think so. Probably your answers will still come out to be negative at the end and you can correct yourself. But this was my logic of putting at least one negative here. I hope I was able to answer your question. No? No, I was not. Yeah, I think this explanation should be enough that For me, the IG alpha will be clockwise and the MAGD will be anti-clockwise. Look at here. Hang on. This is AG. If this AG is also towards right, then MAG multiplied by D will give an anti-clockwise moment. And if the rod has a clockwise alpha, then the alpha will be clockwise. So that's why the MAGD and the clockwise alpha, I put different signs. But anyways, this is the best I can explain at this point. Now finish the question. Please bear with me. I appreciate it. So AAI plus, what is okay, alpha cross R. Okay, bar is initially at rest. I'm sorry, I did not tell you that bar is initially at rest. So bar is initially at rest. Okay, if bar is initially at rest, that is, then what will be the omegas? Then this will be 0 and I will be left with alpha cross R. So now alpha multiplied by cross position of G with respect to A. So position of G with respect to A is negative J, right? And in an exam setting, many students end up making the mistake of positive negative. So you can again see G with respect to A is downwards, right? So G with respect to A is a negative J because my XY positive are in the standard X towards the right and Y upward. Having said that, the AG is 6.6667I, 6.7I that we calculated. This AG X. What is AGY? Any student who can tell us, will we have AGY? Oh, of course. Why? Because the rod can rotate, right? So it will have a horizontal component of acceleration. It will also have a vertical component of acceleration. So it is equal to AI, and we will have alpha. 1.75. No, alpha, I think we found it, right? Yeah, 1.675. Yeah, no, hang on. Have to give me 1 second. Oh yeah, we did find it. So AGX is 6.7. Yeah, thank you. We will put 6.7 here. Then alpha comes out to be in my notes it is 20. Alpha in my notes is 20. And of course it is clockwise because I assumed it to be clockwise. So alpha is equal to negative 20K. No? And there is a square, 2 power 2. Ahmed, this is 2 power 2. You can. Okay, that's fine. Now I will just put alpha instead of alpha. I will, because this is a vector. Please bear with me. The question is over. But I believe that it will make your life easy in an exam because minus 20K. Okay. And then I will just finish it by saying it is minus 20I. So AA comes out to AGY comes out to be 0. Oh, okay. And AA comes out to be 26.7 meter per second square towards right. Oh, okay. Why don't you all have a quick look at it and tell me if it's clear or not? I will again repeat. Summation of moment about center of mass. When the object has rotation about its own center, wheel is rotating, going to the right, coming to the left, whatever. Summation of moment about center of mass is IG alpha. I am allowed to do it. Then summation of moment about a fixed point of rotation is IA alpha. We already know it. But what I just said is that if now the point of rotation is also moving, then you just have to realize that you will have I alpha and you will also have MA D term that will pop up. Is it fine now? For those of you who came 5-10 minutes late, probably you may want to watch the initial 5-10 minutes again, or probably I can just show you and then I have to continue, but I just talked about a quick review of a couple of things that we already have done and what is new in today's problem. Okay, do we have any questions from our online students? Yes, no? Hussein or Abu? No? Okay, because what we went over is, I think, something that may confuse some students. Why don't you do one thing? Why don't you all do this problem? We have a chat from Abu. Okay, unfortunately, I did not bring the diagram. Come on. So let me make this for you guys quickly. Let's say if now I have the same rod that is going to the left. So today I will also post the past paper. Again, this is, there will be a hinge or a revolute here, right? Quickly do it because it will be nice. Revolute or, and this is my point B, and this is my point A, and the force applied is to the left. I hope it looks left. Hang on for a second. Come on. I have to speed up a little. Okay, this is my force applied. This is P. The length of the rod is L. The question says the uniform bar of mass M and length L is balanced in the vertical position when the horizontal force P is applied to the roller at A. Determine the bar's initial angular acceleration and the acceleration of its top point B. Determine the bar's initial angular acceleration and the acceleration of its top point B. So first thing first, if such kind of a question pops up, I have to tackle it. How would I do it? Summation of forces in the x direction is equal to M times A times G times X. Now roller has negligible mass. Don't worry about the roller. Focus on the rod. What is the forces direction? I think it is, let's say, I consider my left side as positive. Hang on, don't get confused. The forces apply to the left, and I also have this intuitive feeling. Of course, the acceleration will be also towards left. Are you getting my point? So in that case, if there is a student of our class who wants to put a negative here and then negative P, then he or she will be right. Otherwise, you can easily get confused. That's why I really want to take my left side as positive. So I will be left with P equal to MAGX. Is this point clear? Yeah, because my MA, I don't play with the MA sign, right? MA, I alpha, I try to consider them with a positive sign, and then I play with the left side. This is where I need your help. So Usman, Bahadur, Ghazal, everyone, Hasung as well. I want you to tell me. Sorry. Okay, summation of moment. First of all, I forgot to make the base. I apologize. I'm so sorry. This is some sort of a table because Otherwise, you cannot even imagine what is happening. So this is some sort of a table on which this object is going. Now you tell me, where will be my point of rotation? Point of rotation.
It's going to rotate around the point A value.
Well, we can. But if you take the point of rotation about point A, then what will happen to the AG will appear? Yeah, I think you are right, but the author has done summation of moment about center of mass. Okay, we will do this problem with both ways. Okay, let's first do with the author's way. So summation of moment about center of mass is equal to IG alpha. Okay, we are all on the same page that when it comes to center of mass, oh come on, it's I alpha. Don't worry whether this point is going to the right or the left or it's moving or not. We have no issues in this IG alpha. I have told you quite a few times. Now let's tackle this IG as 1 over 12 ml square theta double dot. Okay, what about summation mg? Okay, I did not make the free body diagram, but I think even on the free body diagram, I can make just a couple of these fellows. Good, very good. So he already figured it out rather quickly, which I appreciate. Now I will just, for our all students, just to be on the same page. Okay, so we have so let's say this is our mg that is acting downwards. Our normal force here is acting upward. And then we have the P force that is acting towards the left. And you can also make a kinetic diagram if you want. Make MAG and I alpha. So MAG will be to the left. AG will be to the left. And alpha for my kinetic diagram will be clockwise. Okay, do this problem. Everyone, quickly. Alpha. So now I will be left with, as one of the students told us, that we will have P multiplied by L by 2. That will be clockwise, will give me 1 over 12 ml square. Alpha is clockwise. So P comes out to be m alpha by 6 and alpha comes out to be 6p by ml. Correct? And then what will be our AG? So I will do the summation of forces is equal to MA, I already did, and we will get this AG, right? So I will get my AG, which is AGX, by the way, is equal to P by M. And last but not least, I have to find the acceleration of point B. How can I find it? AB is equal to AA plus, not AA, I apologize, AG plus alpha of the rod multiplied by, you can call this rod as AB or BA, whatever, it's entirely up to you, cross position of B with respect to, oh come on, what am I doing? G with respect to, sorry, B with respect to G, correct? This alpha is alpha AB, alpha BG, doesn't matter. Now, what is AG? It is minus P by M I. And what is my alpha? It is
Is it assumption?
what?
Minus.
No. It's clear. It's not even an assumption. Look, Bahadur, if someone is applying a force to the left and I am writing summation of forces is equal to MA, if I ask you where is the force acting towards, you will say to the left, minus P, or to the left. So where would be the acceleration be? To the left. So that's why I took my left side while writing summation Fx as positive. Are you getting my point? When I write summation of forces is equal to MA, then I never put a negative MA on the right hand side 99% of the times. And if when I write summation M is equal to I alpha, 99% of the times I don't want to put a negative I alpha. We usually put the positive signs on the right hand side and then we adjust our left hand side. So if I am pushing something to the right, for sure the acceleration will be positive to the right. The force will be to the right. In this case, okay, I hope I have clarified this. Please let me finish. Where is it? Okay, gentlemen, now we have minus P over Mi plus alpha is what happened? We have a chat message from Hussein. Hochem, why is the omega 0 in the equation? Previous question, right? In the previous question, oh, sorry, in this question. The question says, determine the bar's initial angular acceleration. So Hussein, initially the system apparently is at rest. Even if I forget, you can put it here. That's why omega is 0. Good question, okay? Okay, because if I was talking about an intermediate instant of time, then of course, the system will have an omega. So Hussein is absolutely right. I had to provide you some omega information. Okay, what about alpha? Alpha we found as 6p over ml. So I will write 6p over ml, and this alpha is clockwise. So I have, if you can put it here. So this means this is negative k. Position of B with respect to G is L by 2. B with respect to G is L by 2 J. Correct? So I don't know, why don't you do it and tell me whether you are getting minus P by M I. K cross J is, I don't know. K cross J
is minus I minus K cross J is positive.
Positive I? Okay, please double check. Positive I is 6p over m multiplied by 2. So the answer, and one of the students said it is positive I. So this is minus p over m plus 3p over m, which is 2p over m. I'm not sure why our notes has negative sign. You make a mistake. AG is negative. I don't know. Anyways, so this comes out to be 2p over mi AB. No, I'm sorry. I'm right. So the question says that positive is towards the left. So forget about the author. This means that the AB is towards the right. Yeah, exactly. The author flipped the signs. So now there were students who were saying, do the summation of moment about point A. Why don't you do it yourself? And do you want me to do it? I think everyone wants me to do it. Should I do it? Okay. Well, we can do it if all of you want. Okay. I guess everyone wants me to do it, so we will do it. So again, solution I don't have, but I can try with you, certainly. So summation of moment about the point of rotation, students told me, is equal to, so now I will write Ig alpha plus or minus, minus plus, I don't know, MAGD, because I have this understanding that the point A is going to the left. So you know what, I will have I alpha and MAGD terms, both of them will be scattered. Okay, now here comes the interesting piece of the puzzle. Do I have any external force on this rod that is providing the moment about point A, or am I using my hands to for example rotate this rod? I don't think so. There is a force P that is acting right through A. So I think we have students who are saying right now, why don't you put a 0? Yeah, right? Summation of moment about point A is equal to so I just don't want to confuse you guys. So we will do how we do in our notes. Is equal to 0 is equal to I alpha or I alpha plus MAGD, whatever. Now that we have got this, let's hope that we will get the same answer, by the way. So 1 over 12 M L square alpha, AG is L by 2. Sorry, AG is AG, AGX L by 2. AG is P over M?
Yeah, we calculate by using F is equal to M.
Good. So AG is P by M, as one of the students told me. He said we did summation of forces. So AG is P over M. But minus? Okay, I am doing all of this, but I have to also stop and think about it now.
No.
So yeah, he's right actually, because AG is to the left. So
But always no, all right.
no, 1 minute. Summation of forces is equal to MAG. So AG is towards the left. So what he is saying is, if AG, that's why Ghazal said, let's write minus P over M. So if AG is to the left, then MAG will do an anti-clockwise movement. So you know what, Ghazal? Let's put like this, because MAGD is producing an anti-clockwise moment. Yeah, and the alpha is also, okay, hang on. Look here. The MAG, the acceleration AG of this point is to the left, right? So MAG is acting to the left. This point about point A will have an anti-clockwise moment. So that's, anti-clockwise. That's why I'm saying, so about point A, that's why I'm saying, let's put MAG L by 2 as an anti-clockwise, as a positive moment. Okay. Now what my feel is that when the, when my feel, no, it's not clear. It's not clear to our one student. 1 minute. Look. The
P is applied left. I think.
So the rod will go to the right.
Yeah.
Good.
And if you could.
I agree with you. Look. I completely agree with you. So I will also answer your question. But first of all, you do agree that we have done summation of forces equal to MAG. So if someone is applying force to the left, I know the AG has to be to the left. So far, so good. Let's go back. If MAG, the blue arrow is to the left, that small blue arrow, then about point A, it is anti-clockwise moment. You agree? But the fact is that the rod will go to the right, as you just said. So I will now incorporate your point. So I will put a negative point here, because I alpha will be clockwise. Okay, okay, gentlemen, let us proceed quickly. Now, what do I get? Is equal to 0. Okay, why don't you all now tell me what is P from here? Anyone who can just help us? P is equal to, oh come on, you need to give me right answer, because
6P over ML.
alpha.
Alpha is equal to 6P.
So are we getting the same answer, nahi?
Yeah, but minus. No, yes, same answer.
Okay, I'm so happy because I was trying to clear the confusion. I'm not sure whether you are more confused right now or less confused, but my point is, In an exam setting, when the question pops up, I keep on repeating again and again. When you are doing the summation about center of mass, relax. IG alpha, don't have any qualms about it. The center of mass is moving. Let it move. The object is rotating. That's fine. Summation of moment about center of mass is equal to IG alpha. But the center of mass is not translating. That's fine. Still summation of moment about center of mass is IG alpha. I want to talk about summation of moment about point of rotation. Now you have to stop, take 1 second and make sure, is the point of rotation fixed? Yeah, it is fixed. Then do I alpha, IA alpha, where is the point about which you are trying to take the moments. Don't worry, point of rotation is fixed. You are happy. Summation of moment about point A is equal to IA alpha. The point of rotation itself is moving. Relax. Now you will have a bunch of I alpha and MAGD term. Both of them will be scattered. You have to just relax now. You have to be careful. Just one more remark on this, because every time a question appears, I don't want you to think that there will be a zero here. So I don't want you to think like that. So that's why, just to be clear, if I had used my own hand as well. So for example, I would have put, let's say, everyone, if you can please look here, this is good. Clockwise moment m naught, whatever value, let's say 2 Newton meter. Then I would have scrolled this downwards. Wherever I have summation of moment about G, I would have written here -2 plus. Here I will have to put a -2. Why? Because although this clockwise moment appears to be acting at G, you don't have to make that decision. As long as it is acting on the system, even while talking about the summation of moment about A, now you have to put -2. Now you have to. Even if you think that it is acting at G, you don't care about it. The moment is acting on the system. Even while writing that equation A, I have to talk about -2. Hang on. Please bear with me. I have to now correct myself. Okay. Okay, and okay, let me, before we go on a break, and then when we come back, I think that's enough discussion. I did bring more problems. I can scroll that on the screen, and then we will talk about some equations of motion again, and then we will call it a day. But before I do that, and we go on a break, why don't we just have a very quick look at the 2 whiteboard problems that I did here when we had only 3 students who attended the in-class lecture. So again, you can consider this as your exam preparation revision. This topic. Let's open that nice, beautiful car and motorbike. Where is that car? Yeah, motorbike. So again, students who attended this class, they remember the moment we talked about summation of moment at point B. Hang on. I still remember I said it is equal to IG alpha plus MAGD. And I said, since the center of mass, the person or the bike, G1 and G2 point, they are not rotating. It's a pure translation problem. You only have MAGD. So summation of moment about point A or B. Look at here. Okay, we have this one student as well, everyone else as well. Usman, this is an excellent point. So look, summation of moment about point B. Look at the right hand side. Again, I have gone through this problem if you have been following the classes. Look at here. What exactly do you have in this pure translation problem? MAGD and MAGD. but you don't have IG alpha. Why? Because the biker or the bike itself, they are not rotating. The biker and the bike is in translation. And I always have, even on my notes, I have told you, summation of moment about point A is equal to, in a pure translation, the IG alpha, the alpha will go to 0 plus MAGD. Last semester, when I gave exactly this problem, 80% of the class did not write MAGD. Again, something to think about, something to revise. Okay, let's now open the peeling out problem of the car. Again, focus from the center of mass of the car. Focus from the center of mass of the car. Is the center of mass, I'm talking about the car, is the center of mass of the car rotating? No, the center of mass of the car, the point G, actually is in translation, right? So when you talk about now summation of moment about any point on the object, let's say point A, focus on the point A. Now that you have to write summation of moment about point A, okay, relax, it is equal to IG alpha plus MAGD. Is the center of mass rotating? No. So IG alpha will vanish and you will have MAGD. Again, 80% of the class last time also forgot this. So I'm trying to emphasize. Look at summation of moment about point A. Oh, I'm sorry. The author hasn't done it. Let's scroll down. Yep, here it is. Summation of moment about point A. Focus. The left hand side are the bunch of terms that you have to take care, equal to. Do you have any I alpha? No, because the center of mass is in translation. It's only MAGD term. Okay, let's say have students who are saying, you know what, it's too complicated. If I had to do this problem, oh come on, I really don't want to talk about summation of moment at any other point than G. I want to focus on G. You know what? That's the good part. When you write summation of moment about center of mass, what is the equation? It is equal to IG alpha. Is your center of mass rotating? Students will say, no, it's not rotating. So there will be a 0 on the right hand side. You have to take care of the terms on the left. Boom, the question is over. So again, I intentionally now have covered pretty much every case again. And now I think it's the right time that we can go on a break. But before you go on a break, why don't you all just tell me one quick thing before I say goodbye to you for the break, of course. Can you please bear with me? I have to make sure that come on.
Can you say, for example, P in this way should be towards the right, and always a gyration towards the right. Can you say?
A gyration, no, acceleration of center of mass.
Acceleration of center of mass.
So for example, you can even look at the question. What is this 50, by the way? Summation of x is equal to MAGX.
Magnitude of
Acha, yes. Okay, look, in this question, okay, it's good that you already have started thinking about it. Somebody is pulling to the right. Now, it's again, all of our right now have intuitive understanding. Forces to the right, F equal to ma, let's say summation of all the forces. The acceleration will also be to the right, right? So when you have to talk about summation F equal to ma, it's a good idea that you take towards the right as your positive. So your ma term sign doesn't change. So I agree with you, Bahadur. So can you all just have a look at the solution so I can say goodbye for the break. Spool has a mass of 100 kilograms and a radius of gyration of this. If the coefficients of static and kinetic friction are these, determine the angular acceleration of the spool. Now, when it comes to the friction, its direction and details, I told you that you all can be a little lenient in that aspect of the friction. So other than that, just focus on everything. I wrote the summation of forces in the x direction. I have to talk about friction. So I will take the friction to the right. We have talked about this in this class a lot of times, that sometimes the direction can become tricky. Summation of forces in this FA is that friction. Summation of forces in the y direction is equal to MAGY. Okay. I highly doubt that this spool is flying in the air. So AGY is 0. Like, come on. That's why in AGY to the right, there is a 0 term sitting. Here comes again the revision of the same concept. Summation of moment about center of mass. The center of mass is translating fine. Even if it hadn't done any translation, it had been fixed, fine. Summation of moment about center of mass is equal to IG alpha. Summation of moment about point G, that is center of mass, is equal to moment of inertia about the center of mass multiplied by alpha. Now all you have to do is take the moments. 50 multiplied by 0.25 minus FA multiplied by 0.4, it is equal to I alpha. When you have a no slip condition, then this means the AG will be R alpha. We have gone through this kinematic analysis before. We get the alpha, we get the AG. Now, again, this is something new for you. So students can just have a look here. In this class, I haven't gone through in detail. For a rolling problem, if mu s and mu k are both given, you can have a look yourself. That's fine, actually. Okay, I think that's enough. Now let's go on a break. Let's have a 10-minute break, actually. Let's come back at 11:45. So when you come back, I will just continue with derivation of those equations of motion. And I hope that you guys are feeling better in terms of this summation of moment concept. Okay? Okay. Thank you. Yeah, why not?
Forces.
Yeah, so I will tell you two things. I have
I
covered this. No, I actually have said the same thing in the classes. If the author has taken the friction to the right, then take the summation of moment about the center of mass. This will have an anti-clockwise effect. So you will have a FA multiplied by 0.4. You can see that, okay, anti-clockwise is negative apparently here. So minus FA into 0.4 and plus 50 into 0.25.
Yeah.
My point is, as long as you are consistent, you have made an assumption, but I need to see that you have been consistent in that.
Okay.
Of course, if you take the friction in a particular direction and that summation of moments is not being reflected into your equations, that's where I will start deducting points.
Okay.
But in terms of direction, assume a direction if I haven't given you any information. If I have given you a hint, for example, hypothetically, in this problem, assume the friction to the right, let's say. Then you just follow it. So,
okay. Okay. Thank you so much.
Okay, no worries. Okay, let me already has hit. And last time I was talking about derivation of equations of motion. I will just make this dynamical system. So Euler-Lagrange, I talked about it, but I have to ask you in an exam setting for equation of motion. Newton's law is what I would be expecting. So let's say this is a object. The question says that you have to find the equation of motion for this object. Let's say its mass is m, the applied force is in this direction. Let's say my x is defined in this. So I was telling you summation, what happened? Summation of forces in the x direction is equal to mx double dot. And I told you last time that P, oh, hang on, just for a second, give me 1 second. Oh, sorry for that. Yes. So what we can say is, yeah, I think there is nothing wrong in this one. The reason I have made this is because for students who attended last time, I still remember that I made this dynamical system, and when I said that this system, there is a mass, and I told every student that let's say it is hanging with a spring. Let's say it's a frictionless surface. You can put some massless roller into it just to emphasize that I'm talking about pretty much negligible friction, let's say. And I told the whole class that let's say there is a spring. I hope everyone watched the recording. And I said, what is the equation of motion? I still remember that I tried to explain it to you that what will be the equation of motion? It will be, let's say this is the applied load P, and this is my X. So I told the whole class that it will be P is equal to summation of forces equal to P minus Kx is equal to Mx double dot, and equation of motion becomes Mx double dot plus Kx is equal to P. So I tried to explain to the class why didn't I write the gravity term. So for those of you who attended, they remember the reason. I said that when I'm talking about the equation of motion for this system that has a spring, the fact is that I have considered my X. So let me draw the X for you. I have taken the X in such a way that you hang it. So, and then you leave it, then there will be an initial static deflection. Once that static deflection has happened, then I draw a line and I said from here onwards, I am defining my X. So since I have already taken into account the static deflection, that's why the mg term doesn't pop up. The sole existence of the sole reason of m, in this case, it will be mg sine theta. The only reason mg sine theta term is not popping up if this is theta is because that mg sine theta is responsible for initially deflecting that mass, or for that matter, if you have a mass on the top of a spring, that little sinking in that happens is because of static deflection. So the reason I made this equation of motion is because I didn't want all of you guys to think, oh, you know what, mg sine theta can be ignored. Oh, come on, mg sine theta cannot be ignored. You cannot ignore mg sine theta. For the spring, the reason of not writing was that, but right now today when I have to talk about equation of motion, oh come on, I have to talk about mg sine theta, which makes complete sense if you talk about it. The fact that I am applying a force is equal to mx double dot plus mg sine theta. So if I'm pushing the mass, my energy is, my force is being spent into working against the weight component as well as accelerating the object. Let's talk about something more. Is this clear, right? Yes, no? Okay. Okay, now let us see everyone's imagination. Let me draw a little more complicated system. Okay, equation of motion using Newton's law. So why don't you all do this problem for me? We will have a revolute or a hinge. And now I will draw this system. It has a spring and I have a bob. This is mass and your spring is massless. This is L plus theta. I'm sorry, theta. I apologize. Now, the length is L plus R, the total, the length. And there are a lot of students who are saying, what is the meaning of L plus R? Okay, again, I will tell you the meaning. So unstretched length of the spring is sitting here, that is L naught. I hung it with the mass, then I gently left it. So of course the spring will stretch because of the fact that there is a mass that is attached to it. You get my point? So that length is L, and for me the R is I'm defining once that static deflection has happened. I hope it's clear. So R is defined such that static deflection has happened because of the weight. Now, if there is a student who doesn't agree with it, then that's fine, but his answers will have the weight scattered all over the place. So now comes the real question, how are you planning to approach this problem? It's so easy, right? First thing first, you have to draw the free body diagram. Once you draw the free body diagram, oh, come on, I'm not going to do it separately. Let me just draw everything with a yellow marker. So the first thing first, I will have force here, right? That will be spring force. Okay. This will be weight. Agreed. Okay. Anything else? No. Then I will have the components of this beautiful weight. One will be this one. The other will be this one. This will be angle theta. So this will be my mg cos theta, and this will be mg sin theta. Okay, finish the question and tell me the answers. So I will have summation of forces in the radial direction is equal to MAR, and summation of forces in the theta direction is equal to MA theta. Oh, come on. If you do the X and Y, it will be complicated. 11:57, 12:02, I will not do anything and you will do it. I'm telling you, you can do it. With the background you guys have, I'm 70%, 90% sure, 100%. It looks very complicated, but it is doable. R is your variable. Okay. So focus on two things. What are your variables, or let me put it like this: what are the degree of freedoms? You have actually 2 degrees of freedom, and again, it is a little complicated system for a 208 course, but that's fine. Theta and X, theta and R are your 2 degrees of freedoms. Is there any applied moment? No. Is there any applied force from me? No. This system will only move because of the initial conditions. So that's fine.
So the question asks for
Equation of motion. Just give me the equations of motion by Newton's law, or in other simple words, write the 2 equations using summation Fr is equal to MAR and summation F theta equal to MA theta. Now that we have a couple of students, I think, who have tried, I will try to write it. Summation of forces in the radial direction. Now, we in this class have taken the radially outward as positive. So, let me, sorry for that. I have just my, okay. So if the radial outward is positive, just to clear, this is my R, right? Or E caret R. And what is my E caret theta? It will be right like this, right? Okay, do it. So you will have mg cosine theta. Agreed? Correct? I hope everyone has this term. Minus k multiplied by r, fs, as Usman said, I agree, equal to m multiplied by ar. Anyone who remembers the ar formula? It was r double dot, right? R double dot minus R theta dot square. Does it ring bells? AR is equal to R double. Okay. So R double dot, be careful, R double dot minus R theta dot square, right? Okay. Everyone agrees what I just did? Of course, if my formula has R, if I give you L plus X, you have to use L plus X. If I give you S plus T, you have to use S plus T. Whatever I have as a position vector, I have to use that. Now I have to ask you the next question. In L plus R, what exactly is your variable? The R, because the L is something constant. Okay, so you will actually remove this chunk and you will have a very nice, beautiful equation within the next 30 seconds. Mg cos theta minus kr equal to m r double dot minus L plus R theta dot square. Sorry. I made some mistakes. Yes, please. What is the next mistake? Really? M? M. Good. M. I think every student is correct. M double dot minus M into L plus R theta dot square is equal to minus KR positive mg cos theta. And we have a lot of students who are saying, why don't you write it like mr double dot minus m L plus R theta dot square minus mg cos theta plus kr equal to 0. Now what is left is for you guys to do this. Now I am 100% sure you can do summation forces in the theta. I'm sure you can do it. If you can all please tell me how would you approach summation of forces in the theta direction is equal to. Good. Okay, you already have started to tell me the answer. Minus mg sine theta yeah, hang on for a second. Okay, sorry. M minus mg. Okay, we have y is L double dot 0 because the length L doesn't change. The L dot and L double dot are 0 because it's L plus R. The L is the length that remains fixed, right? So for example, if you have unstretched length of the spring, you hung it, because of the weight of the mass, you have that sinking in kind of a thing, but that length is L. It doesn't change throughout the motion. The R makes the total length as L plus R. L plus R changes, L doesn't change. I get it. Okay, no worries. Last but not least, you have minus mg sine theta. Yeah, is equal to, then you have m into r theta double dot, r theta double dot plus 2r dot theta dot, and then I have m into L plus R theta double dot plus 2R dot theta dot. You can take this plus mg sine theta equal to 0. Now the last question is again 2 degree of freedom system, I understand, but can anyone tell me which is the equation of motion? Last question. What happened? You can always ask me. You can always ask me.
I asked hocam why R is not zero. R double dot is not zero.
I will tell you why it's not
Yeah.
zero. Because at the end of the day we have a spring, right? We have a spring, and the look. So this whole thing is sitting here. I have to give an initial condition. So what I did is I stretch it a little bit, and let's say I also take it to a theta angle, and I leave it. So this thing will bounce up and down, and it will also go like this. That's why your R double dot is not zero. R dot is not zero. Can anyone tell me what is the equation of motion between the two of them? Huh? Both of them. Very good. So both of them are your equations of motion. This is equation of motion. This is also equation of motion. You cannot just write one and leave the other. Why? Because how many unknowns you have in this? Two unknowns. You have two unknowns. One unknown is R. The other unknown is theta. And how many initial conditions do you need? Let's say someone deflected this 0.1 centimeters downwards, and someone also gave a push, so that R dot at 0 is let's say negative 0.02 by 100. That's really less, by the way. I'm not sure why. Then doesn't stop here. Someone also took it to 20 degrees anti-clockwise. Let's say you can take it clockwise as well. We don't have any issues. And someone also give it a push. Theta. Okay, I don't have space. What should I do? Let's write here theta dot at 0. Let's say someone give it a clockwise. Again, it's entirely up to us. 0.5 into pi by 180 radians per second. I apologize that I put a, after pi by 80, I put a degree. I have to put radians. I'm sorry. So how many initial conditions? 4. How many degrees of freedom? 2. This is a complicated system. This is a complicated system for you guys. So you don't worry. I will make an exam that is doable, but I'm just giving you a flavor of how complicated systems can be. So you know what? I will make another 2 degree of freedom system, but this time I will make it a little easy for you, because so this is also 2 degree of freedom, but something tells me it will be easy for our students. So let's say this is supported like this. Someone is applying a force, let's say P. Please bear with me. Okay, what is the deflection? We have a student who has, what was asked to be found in the previous question? Equation of motion. Okay, thanks for bringing this up. EOM. Yes, please.
Hocam is the alt plus are given in the question.
or just the answer is linear, things like that will think how is the situation.
You have to repeat one more time.
I mean, L plus R is given in the question, or we are thinking like it's L and it will be alpha.
Oh, okay, okay. So I understand the question. His question is more like, do we actually know that it is supposed to be L plus R, or we just have to ourselves take this decision? You don't need to worry about this. If in a very hypothetical scenario, I have to give a difficult question like this, I have to guide you a little bit that you have to take it as an L plus R. It is difficult for a student to think. So what is the answer? Oh, the yellow box and this yellow box are the answers. This yellow box is the answer. And this yellow box is the answer for the second problem. Did I? Oh, okay. Yes, yes. But it is a good question, by the way, because many times back in the student days, I used to ask as well, what is the answer? So now, last but not least, what is my x defined? This is my x defined. And it makes more sense that I please put the load on the object, because the last thing I want is our students getting confused why the load is applied like this. Okay. This is P bracket T. So just to make it a little complicated for our students, I am putting a spring again. Okay, and let me make that little box again. And let me put it like this. And let me call this as M1. Let me call this as M2. Let me put a damper as well. And yes, this is a vibration problem. Good. So our students have figured it out that this is a vibration problem that you are making. Okay. So this is, let's say, C1, B1. In O2, we are using B for the dampers. K1, K2, B2. And last but not least, we have to define that this is my X2 bracket T, and that was my X1, by the way. And yes, no friction. I'm not taking any friction. The problem will keep on getting more complicated. We can do that, by the way. Okay, now I have a force. Let's call it as P2. This one is P1. So just do it. Summation of forces in the x direction is equal to M1 X1 double dot. Okay, free body diagram. I'm sure you guys are comfortable now. What is that? If the X1 is positive to the right, my spring force will always oppose it, right? So it will be X1 minus, what is the deflection of this point? 0. Good. Okay. What about the damper? Damper has velocity terms x1 dot. And what is the velocity? Good. Thank you. Okay. Then what is the direction of the applied force? It is P1T, in the same direction as my positive x. And do I ever try to play with the signs of the right hand side? 99% of the times I never change the signs of my MA terms. I consider that as my positive. So it is M1 X1 double dot. Done? Okay, this is your first equation of motion. Please double check. I hope it's not wrong. Looks correct, by the way. Second equation of motion you write, and I will make one more equation of motion and we can end the semester. I will again repeat, Euler-Lagrange is not coming in your exam. It's complicated for you guys. You can write, right? Should I do it? Okay, I think I will do it. So the second will be minus K2 X. Nice, nice, very nice. How did you figure it out, by the way? I'm impressed. K2 into X2 minus X1 minus B2 into X2 dot minus X1 dot plus P2. No, 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 no. No, just P2 is equal to M2 X2 double dot. I drew the, now I have to draw the free body diagram because our students are getting confused. Draw the free body diagram of M2, draw the free body diagram of M1, then talk about everything. So let's draw the free body diagram. You see, that's why free body diagrams in your physics classes, I'm sure your professors went over it in detail because this is very important. Don't take the decisions without free body diagrams. I thought that I should directly write it, which was not a good idea, by the way. Am I recording? Okay. This is mg. Then there is a normal force. Then I have good. Fs2. Then I have damping force. Let's call it as Fd2 or B2, whatever. I'm sure now you can do it yourself, but anyway, so it's P1 function of time. Then you have M, oh, come on, M1G, M2G, N2, and here you will have N1, and this is Fs. Now, last final exam, I gave this problem. I think all of you really would want me to do that problem. So let me do that problem. Okay, let's finish this. So this is 2, correct?
Question will be give the, for example, x1 that or x2 that. Is it given a question? Or?
Just 1 second. Sorry, say that again. X1 and X2.
Yeah, it's initial conditions.
No, initial conditions I did not write. I have to write it, but you mean X1 and X2, and will this symbolic notation be given to us or not? Yeah, symbolic notation will be given. Initial conditions I did not give you. I have to give you, but I can write the initial conditions right now. Somewhat X1 add.
So it's will give any question.
These symbols, yeah, X1, X2 symbols, K1, K2 will be given. Can you just let me double check if I made a mistake or not? K2, X2 minus X1. Yeah, it seems correct, by the way. I think so. Okay, let's finish our semester by doing a problem similar to which I gave in the last semester's final exam. Now, again, I'm just telling you how to prepare. If I were you and I had to prepare for a final exam, I will definitely from rigid body kinetics. Let's say if I have to prepare first, I will definitely try to go over the examples that I have done in the class just quickly, so that the strategy is clear to me. The car problem, the motorbike problem, then I will definitely go over those rod problems, all of them that we have been doing in class, just to clear when ml square by 12 comes, when ml square by 3 comes, summation of moment, how I do it, summation of forces, how I do it. I will definitely go over the problem in which the yo-yo problem in which we were pulling it and it was going up, or in another problem there was a rope there, another rope there, we were trying to pull it. I will definitely yeah, this is how I will start my preparation. So let's finish our semester. I will say goodbye to you on this problem, similar to which I gave in the last. So we have, the problem says, let's say that we have hang on, let me make theta in such a way that I don't struggle with the, at least with the explanation. You have to make the equation of motion. Let's say I have hang on. Sorry. No. Like this. So this is, let's say, a torsional spring. And this is my theta. And this is my, let's say, L by 3. And this is my 2L by 3. The question says, find the equation of motion. Oh, you mean applied moment? Okay. So first of all, even if I don't give you an applied moment, this system will work on the initial condition. I will have to stretch it at 10. It will keep doing it. But his question is, are you sure? Is there any applied moment? So let us make the question more complicated. Let me put an applied moment as well. M node. Okay, equation of motion, how will I do it? Very easy. Summation of moments is equal to, let's call this as point A. Let's call this point C and B. In fact, you know what? And let's call this as point G. So C, A, G, B. So summation of moment about point of rotation is equal to, okay, is my point of rotation flying in the air towards the right, left? I don't think so. It's fixed. Seems to me as fixed, right? So yeah, I hope so. In fact, you know what? It is pinned very close to it, just so that no one gets confused. It is pretty much only rotates here. So summation of moment about point A is equal to IA alpha, no qualms about it. Okay. One of the students asked about the moment, so I added it. So what is my applied moment? M node is equal to IA theta double dot. So give me the IA and I think the problem is over. No, sorry. There is one more thing. I apologize. We have a torsional spring as well. Oh, come on. How can I forget? Minus K theta, which will be the torsional spring, multiply by? No. So if my spring force is Kx, nice. Everyone figured out how he figured out? So instead of X for torsional spring, K theta, I will have a theta here. So I guess this is how he figured it out. It is equal to IA. Okay, so we will have M node minus K torsional spring theta is equal to I A theta double dot. What is the moment of inertia of the rod about point A? Find it out and let's finish the semester.
If the rod has a mass.
M, yeah, for
Just
sure,
M.
of course. M. This is the mass. M. So it will be M L square by 12. Students told me about the center of mass. What is the distance of the center of mass to the point of rotation? If this is L by 3, this is 2L by 3, this is L by 2. You have to calculate. I have no idea. Sure. Okay.
Yeah, the distance between A and G, right?
The distance between this was A and G. L by 6. So one of the students told me that A and has distance of L by 6. So I will agree with him. M R square. Then I will put a bracket theta double dot. So I wrote IG plus MR square or MD square, whatever. Entirely up to you. I think the way you have found is you did L by 2 minus L by 3. Yeah. L by 2 minus L by 3. 3 2s are 6. And 3 2s are and 2 3s are. Yes. Good. So, well, gentlemen, this brings us to the end of the semester. This is the equation of motion. Not sure whether it was confusing or not. This question I gave, I think, in our last semester. How many initial conditions? 2, because it's a second order differential equation. What will be the initial conditions? Theta at 0 and theta dot at 0. How much will you deflect it from its equilibrium position?
What do you mean by how much width deflects?
How much will you get? I mean, let's say if when I made this system, I put the torsional spring and this rod in such a fashion that, let's say, the rod is sitting horizontal at equilibrium, even in the static deflection and everything. Okay, I'm not talking about the torsional spring is adjusted like this, that when I hang it or fix it, it deflects a little bit. Let's say, or let's say, even if it has already deflected a little bit, that line is from there I am defining my theta. So when I say how much I deflected, now that it is sitting like this, how much theta at 0, how much I deflect, how much I rotate it by deflection, and how much I rotate it further for it to go like then for the system to work, along with the fact that I'm also applying a moment. Now, if you disagree with it and say we don't need to give an initial condition because I already am applying a moment, well, I agree with you. So let's say, forget about the initial condition. The fact that I'm applying a constant moment on the system will be for sure enough for the system to oscillate, do whatever it wants to do. But 2 possible initial conditions will be theta at 0. So let's say you are giving it clockwise 0.1 into pi by 180 radians. And you are also planning to give an initial, let's say, counterclockwise 0.2 into pi by 180 rad.
Why I is ML squared divided by 2?
Yeah, because I will tell you. If this torsional spring was sitting right at the center, then that center point is also the point of rotation. You will write summation of moment about the point of rotation, or the center of mass for that matter, is equal to I theta double dot. Good. You will Google the moment of inertia of a slender rod about the center. Google will tell you ml square by 12. You will put ml square by 12. We are all happy. The problem is I made the problem a little different. I said the rod actually rotates about point A, not G, because that's where I put the torsional spring. Both of us agree that a rod that can rotate right about its center and a rod that has to rotate about point A, both the rotations have to be different. Come on, they cannot be same. So when I am about to write IA theta double dot, I have an immediate question from you. What is IA? You will immediately tell me that I will have to use parallel axis theorem in order to find IA. It will be IG plus MR square. Now, when I ask you, how do you write this? You will tell me it is parallel axis theorem from my physics classes. So if you look very carefully, this IG, you see from there, and this is your R square. I am trying to use a parallel axis theorem.
There is are this distance between G and A?
Am I going to give you?
Basics, like the rod above center and
Absolutely. Moment of inertia information has to be provided to you, otherwise you won't be able to work. But you need to know how to use the parallel axis theorem at least. How to use the parallel axis theorem. Okay. On that note, once you have revised the notes, final exam that I will try to post as soon as possible on O2 class. Open that final exam and try to do it by hand so that you get comfortable. Have a good final and have a good rest of the semester. Bye bye everyone. Thank you. It was nice having you in this semester. Bye bye. Thank you. Yes.
You say two situations, the moment of inertia, I think. One situation, ml square divided by 12, and the other situation is ml squared by 6 or 3.
3.
What situation, hocam? It's also rotating, or?
Ek minute. You're talking about the two cases.
Yeah.
ml square by 12. Which one? In this slide?
No, hocam,
Okay, got it. Two cases.
Slides,
Okay, I will understand. Okay. This is a rigid rod. It has mass m. This is theta. So if you have to talk about, this is A, then moment of inertia of this rod about point A is m. This is the center of mass, G, ml square by 12 plus m multiplied by L by 2 square. So it comes out to be ml square by 3. The IG is ml square by 12.
Okay.
Moment of inertia of the rod about its center is ml square by 12. Moment of inertia of the rod about point A is about its one end is ml square by 12 plus this little term that will give you ml square by 3, and you can always Google it.
Okay. Thank you, hocam.
Thank you. Have a good day. Bye-bye. Okay, I think did I make a mistake here? Minus K2 into K1 into x1 minus 0 minus K2 into, I don't know. I think this will be negative, but anyways, I have a strong feeling. Anyways, as long as you understood the concept, minus K2 into Okay, we can now go to our office at 12:45. I will show you your exam papers minus K2 into x1 minus 0, x1 minus x2. Yes, now it is correct. Yes.
Can you get each of the grades?
Yes, you can come to my office right now. Yes, right now. Yeah, and I can show you your grades. Okay, thank you, Abu. Bye bye. I will be in my office at 12:45. I always have to take some time to shut the laptop and everything. TZ29. Okay, Abu has sent us a message. Bye bye. Thank you. Bye bye. Little correction. Okay, this is the correction, by the way.